This simulation experiment was conducted on PCTran, a software that simulates in real time the operations of various nuclear reactors. This experiment analyzed the Westinghouse AP1000 reactor, which is a pressurized water reactor with improved use of passive nuclear safety. The various experiments simulated increasing and decreasing thermal power output through control rod leading, turbine leading, and reactor shutdown, otherwise known as SCRAM. These processes and the results of these experiments will be analyzed in the following video.
The first experiment involved increasing reactor power by inserting the rods from 2% insertion to 15% insertion, and then reversing this process. The reactor was allowed to stabilize at various increments, various temperatures, power levels, and the pressurizer data was recorded. This data shows how leading the reactor through altering the control rod insertion results in a relatively slow and steady change in reactor operations and a large reduction in the overall thermal power output. All reactor operations such as the turbine demand, pressurizer level percentage, and the temperatures change as a direct result of the changing reaction rate that results from the change of the rod insertion levels. Reactor power does not change linearly with control rod control, as the reaction rate does not have a direct linear relation to the control rod insertion percentage.
The second experiment involved leading the reactor through controlling turbine demand. Turbine demand was also decreased from 100% to 85%, similar to the rod leading experiment. Since this results in an instant change, the reactor responds less smoothly even though this is a more realistic